Welcome to this explainer. Today, we're doing something really cool. We are taking a massive narrative journey through time. We're going to travel back over 2,000 years to track down the absolute origins of the digital world that we interact with every single day. I mean, if you've ever looked at your smartphone or fired up your GPS and wondered how all that invisible, complex architecture actually got its start, you are definitely in the right place. Let's get right into it. We're going to kick things off at the United Nations headquarters in New York. Recently, India's External Affairs Minister, S. Jaishankar, inaugurated this really momentous exhibition. It's titled From Shunya to Ananta, which translates to Zero to Infinity, and it puts India's monumental mathematical heritage squarely on the global stage. It was just this incredible moment where world leaders came together to recognize these profound, ancient scientific traditions that literally laid the groundwork for modern civilization as we know it. And seeing all of this heritage laid out raises a super fascinating question. One I want you to keep in the back of your mind as we go through this. Where does the code powering our modern world actually begin? Because, we always tend to think of computing as this distinctly modern thing, born in some mid-20th century lab, right? But the truth is, the foundational logic, the actual seed of the digital age, was planted thousands of years ago in ancient India. So here's our roadmap for this explainer. First, the Zero to Infinity exhibition. Then, we'll look at the birth of zero. After that, we'll meet some ancient masters of mathematics, see how they went about charting the infinite, and finally, connect all of that to the modern world. Section 1. The Zero to Infinity exhibition. The global stage. What's so great about this exhibition is how it mashes up the past and the present. It doesn't just slap some facts on a wall. It pairs these fragile, physical replicas of ancient texts right alongside completely modern digital interactive displays. And by charting that specific conceptual transition from Shunya, zero, all the way out to Ananta, infinity, it really brings abstract math to life. You physically see how human understanding expanded from total nothingness to literally everything. Moving on to Section 2, the birth of zero, Shunya. Okay, before zero is a number we could actually calculate with, Shunya started as a profound philosophical idea. I mean, think about it. How hard is it for the human brain to mathematically represent nothing? At first, a blank space was just used as a placeholder in equations. You needed something there to make the math work. But Indian mathematicians did something totally revolutionary. They took Shunya from being just a blank space and turned it into a foundational mathematical numeral with its own strict set of rules. And without treating zero as a functioning number that you can add or subtract, the advanced math required for modern engineering, it simply doesn't exist. And we can actually see the exact moment this brilliant concept takes shape. You're looking at a replica of the Bakshali manuscript. It's this incredibly fragile document dating all the way back to the 3rd or 4th century. And right there, among the ancient scripts on birch bark, is the earliest recorded use of the symbol for zero. It is absolutely breathtaking to realize that a simple dot, inscribed on decaying bark, is the direct ancestor of the binary code that is processing the digital world around you right now. Now, this evolution obviously didn't happen overnight. As we just saw, back in the 3rd and 4th centuries, zero is just starting out as a placeholder. But fast forward to the 7th century, and a mathematician named Brahmagupta steps in and officially defines its properties. He literally writes down the laws of computing with zero. He figures out that subtracting zero from a number leaves it unchanged, and multiplying by zero results in zero. He made it a formal numeral. And from there, it travels across continents and centuries straight to the modern era, where zero pairs up with one to create the entire binary foundation for global computing. Section 3. Ancient Masters of Mathematics, the Architects. It is honestly staggering when you look at the immense scale of individual genius stretching across time here. In the ancient era, you have Aryabhata. He wasn't just messing around with basic counting. He was providing highly accurate approximations of pi, and he developed the decimal place value system we still rely on every single day. Jump ahead to the medieval period, and Bhaskar II is making these massive leaps in algebra, even tackling the totally mind-bending concept of division by zero. And then, jumping to the early 20th century, we have the legendary Srinivasa Ramanujan. His work in number theory and infinite series was so completely revolutionary that modern mathematicians are still in awe of it today. It's just this unbroken, world-changing lineage. Section 4. Charting the Infinite, Ananta. You quickly realize these mathematical leaps weren't just about practical, everyday numbers for trade or agriculture. They were these ambitious, cosmic attempts to literally chart the infinite.
Early Vedic mathematics involved constructing highly complex geometric altars, which is all laid out in the Sulba Sutras. This wasn't just religion, it was the birth of advanced geometry to ensure cosmic alignment. Indian scholars even developed the Bhadyana Pythagorean theorem way before it was popularized anywhere else. We're talking about the absolute origins of algorithms, the pioneering use of negative numbers, early combinatorics. But maybe the most mind-blowing fact? Their mathematical explorations into infinite series actually predated the development of European calculus. They were mapping the mathematical cosmos long before the modern era even started.
Section 5. Powering today's modern world. The invisible foundation. So, this is where it all comes full circle. There is a direct, invisible thread connecting that ancient wisdom straight to your present reality. Those ancient Indian concepts, early binary enumeration, the origins of algorithmic thinking, those highly sophisticated planetary models, they map perfectly onto the modern world. They are the actual foundation for the computing code running your laptop, the artificial intelligence making incredibly complex decisions, and the global GPS systems guiding your car right now. Without those ancient breakthroughs, our modern technologies just don't exist. It's one long, continuous line of human innovation. As we wrap up this explainer, I want to leave you with a thought, because this really changes how you look at the world. We've just seen how centuries of brilliant minds managed to transform the idea of nothing into the code that runs our entire civilization. So, if ancient bark manuscripts from the 3rd century ultimately paved the way for the digital age and artificial intelligence, what mathematical concepts are we exploring right now, today, that are going to define the next 1,000 years of human history? It's pretty wild to think about. Thank you so much for joining me on this journey today, and I really encourage you to keep digging into these fascinating connections.